First, if you go to this link, you can download the Arduino IDE. For Windows, there are installation files as shown above, as well as compressed files, and you can also download it through the Microsoft App Store. It is preferable to install using the ATS installation file or the App Store rather than the compressed file, because the necessary drivers will be installed at the same time. Therefore, it is better to avoid the compressed file method. For Linux, you should download the version that matches your Linux environment, extract it, and run it. For Mac, you can also download the file from here and install it. If you are a developer who is already using Homebrew on a Mac, you can easily install Arduino by entering the command like this through Brewcask. Next, I currently have an Arduino Uno compatible board, and there are a huge variety of types for this Arduino Uno compatible board. What I have is a genuine Arduino Uno, and since it uses the same USB driver, it usually gets recognized immediately when connected. The USB driver is supported on both Windows and Mac, so it connects right away. However, there are some cheaper Arduino compatible boards that may not have the correct USB driver, which means the Arduino IDE won't recognize them. In such cases, you need to install the USB driver, and most of the time, the driver used is called CH340. You can find a link here to install the CH340 USB driver. Just download and install the driver that matches your operating system. If it's not CH340, but another driver, you can search on Google or similar sites, and you should be able to find the driver. So you need to install that driver in order for the Arduino IDE to communicate and be usable. Let's run the Arduino IDE once. When you launch the IDE, it is quite simple to use. The code and editor sections are mainly highlighted, but for those who have used Artman Studio or Visual Studio while developing with ABR, there will be quite a difference. As a note, it's better not to demand too many debugging related features from Arduino. For your reference, you should understand that simply setting breakpoints won't work. Instead, it's better to think from the very beginning that you will indeed need to debug using serial communication. I will actually organize a separate lecture on debugging with serial communication later. Now, let me show you what the IDE looks like and provide some simple settings after installation. In the Arduino environment settings, you will find preferences in the operating system. If you go into preferences, there are options for show line numbers and enable code folding. These might not be selected by default, but if you select show line numbers and enable code folding like I did, it will be more convenient to use. If you find the Arduino IDE too frustrating later and want to use something else, you can add the Arduino extension in Visual Studio Code, VS Code, and write your programs there to utilize Arduino features. Alternatively, you can create an Arduino project in Microchip Studio, which has been renamed. For now, I will explain using the Arduino IDE. If we take a quick look at the menus in the Arduino IDE, under the File section, you will find examples and a list of recently used files. Projects, here we refer to projects as a sketchbook. You can see things related to the sketchbook, and examples are provided based on the libraries currently set up for Arduino, as well as basic Arduino, examples outside of those libraries. So, for developers who are curious, you can find the desired examples here. The editing part is just related to the editor, and let's take a look at the sketch section. In the sketchbook section, you will find options like verify, compile, and upload. I will explain these in more detail next time, but these are related to the icon commands in the IDE, so I will skip over that for now. You can also include libraries to call the desired libraries. Next, you need to pay close attention to the Tools section. When you connect your Arduino to use it, you need to select the board and the port. Depending on whether you are using an Arduino board or another board or hardware from another manufacturer, you can choose accordingly. Right now, the default is currently set to the Arduino ABR board. Next, I haven't actually connected the Arduino Uno via USB yet, but if I do, the port will be recognized like this. So when you use it, just select the board and then select the port. You can choose it just like this. Next, one thing to be cautious about for Mac users is that there is a slight bug. Specifically, this bug occurs when the input language is currently set to Korean instead of English. In this scenario, if you enter a shortcut key, the command for the shortcut key is registered twice, which can be quite frustrating. For example, creating a new project or a new file uses Command N. So if I press the shortcut key once, it will actually execute the command twice. This can lead to unintended actions and can disrupt your workflow. One possible workaround is to ensure that your input language is set to English before using shortcut keys. Another solution could be to manually undo the extra command if it gets executed. There is a bug that can occur when commands are entered twice like this. Occasionally, when using shortcuts on a Mac, it's a good idea to check whether the current input language is Korean or English before using the shortcut. If not, you might end up uploading twice or performing other actions twice, which can lead to some inconvenient situations. So, it's advisable to check those things. Next, if we take a simple look at how Arduino operates in a straightforward manner, we can see that when a new sketch is created, in the process, there are only two functions in the code, setup and loop. So, how does Arduino work? Essentially, after booting up, the setup function is executed only once, and then the loop function continues to repeat over and over again. Originally, Arduino is structured as a C++ project. However, when I mention it as a C++ project, developers usually ask, where is the main function? In the case of Arduino, when you write a sketch, the Arduino IDE wraps the code according to the specific board or environment and then compiles it. If I show you the source code, this is the internal code within Arduino. Here is the main function part, and you can see that after functions like init and init variant are executed, the setup function we saw earlier runs once, and then the loop function continues to execute within an infinite loop. So, when we looked at the IDE earlier, you might have noticed that there is a setup and a loop, where setup runs once and the loop keeps repeating. Developers will understand that this is the structure it follows. For now, I think that's all you need to know about the Arduino IDE, and I will explain more details as I proceed with the lecture. To get started, you will require some additional hardware. DeviceMart sells the Arduino Uno as a standalone item. If you already have various jumper cables, sensors, or actuators, you can simply purchase the standalone unit. However, if you don't have any of these items, DeviceMart also offers kits for sale. You can buy a kit and use it a bit more. In this session, we set up the Arduino IDE and then looked at how Arduino operates fundamentally. In the next session, we will try controlling the Arduino. Digital pins, GPIO using Arduino. Then I will see you next time.